Ever need to make a remote MCP server appear local or bridge between different transports without changing your client code? We'll create a transparent proxy server that automatically forwards all MCP protocol features, sampling, logging, progress updates, while maintaining session isolation for safe concurrent operations. You'll see how just 5 lines of code can expose any backend server via your preferred transport, with the proxy client handling all protocol compatibility behind the scenes. From FastMCP, import FastMCP. From FastMCP server proxy, import ProxyClient. Create a proxy with full MCP feature support. Proxy equals FastMCP as proxy. ProxyClient, backend server Pi. Name, my proxy. Run the proxy, e.g., via SDDO for Claude Desktop. If name equals main. Proxy run. This demonstrates the proxy pattern for MCP servers, creating a transparent intermediary that forwards all requests to a backend service while maintaining full protocol compatibility. The proxy server doesn't implement its own tools or resources, but instead delegates every operation to a remote MCP server through a proxy client instance. The distinctive capability here is automatic handling of all MCP protocol features, including routes, sampling, elicitation, logging, and progress reporting, without requiring manual configuration for each feature. The pattern works by establishing a clean delegation layer where the proxy server manages client connections and session isolation, while the proxy client handles all communication with the backend server. Each client request automatically creates an isolated backend session by default, ensuring safe concurrent operations without context mixing. Transport bridging becomes possible by specifying different transports in the run method, allowing scenarios like exposing local servers via HTTP or tunneling remote SSE endpoints to SDDO, though these require explicit transport configuration not shown in this basic example. This approach solves critical deployment challenges like controlled access to remote services, transport compatibility, and session management. It's particularly valuable for exposing local development servers to remote clients or consolidating multiple backend services under a single endpoint. The trade-off is the inherent latency of forwarded operations, making it less suitable for performance-critical scenarios where direct server mounting would be more efficient. For basic use cases, the proxy requires no special configuration beyond specifying the backend server location. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for building MCP-compatible tools and proxy servers. It handles all protocol features including routes, sampling, logging, and progress reporting while maintaining transparent compatibility with MCP clients. The class enables creating proxies that forward requests between clients and backend services, automatically preserving all MCP protocol capabilities through the ProxyClient transport handler. For non-SDDO transports like HTTP, you configure them explicitly in run with parameters like transport equals HTTP and connection details. From FastMCP server proxy, import ProxyClient. This imports ProxyClient, the transport abstraction layer that handles all MCP protocol communication between your proxy and the backend server. It automatically manages serialization, connection pooling, and protocol features like routes, sampling, and progress reporting. No manual configuration needed for basic use. The client ensures full protocol compatibility while letting you focus on the proxy logic rather than transport details. For advanced setups like HTTP bridging or custom transports, you'd configure these in proxy.run with explicit parameters. Create a proxy with full MCP feature support. Proxy equals FastMCP as proxy. This creates a FastMCP proxy instance that forwards all MCP protocol features: routes, sampling, elicitation, logging, and progress reporting, transparently between clients and your backend server. The Proxy client handles backend communication while preserving full protocol compatibility, automatically managing all MCP-specific operations. For different transports like HTTP, you'd configure them in run, for example, Proxy. Run transport equals HTTP, host equals 0, 0, 0, 0, port equals 8080. The proxy pattern here is ideal for exposing local servers remotely or consolidating multiple backend services under a single endpoint.
Proxy client, backend server PI.
Instantiates Proxy client with the backend server script as its target. This creates the transport handler that forwards all MCP protocol operations: routes, sampling, elicitation, logging, and progress reporting to the specified backend while preserving full protocol compatibility. The proxy automatically handles all protocol features without additional configuration, making it ideal for exposing local servers to remote clients or consolidating multiple backend services through a single endpoint.
Name my proxy.
Assigns a human-readable identifier to the proxy instance. This name appears in FastMCP's logs, admin interface, and error traces, enabling clear distinction between multiple running proxies during debugging. The proxy client automatically preserves all MCP protocol features: routes, sampling, elicitation, logging, and progress reporting without additional configuration. Closing parenthesis finalizes the FastMCP as proxy configuration, completing the proxy setup with the specified proxy client, backend connection, and assigned name. This creates a transparent intermediary that preserves all MCP protocol features: routes, sampling, elicitation, logging, and progress reporting, while forwarding requests between clients and the backend server. For different transports like HTTP, you'd configure them in proxy.run with explicit parameters like transport equals HTTP, host, and port. The basic setup shown uses SDDO by default, suitable for local development or CLI tools like Claude Desktop.
Hash run the proxy, e.g., via SDDO for Claude Desktop. If name equals main.
Standard Python entry point guard that ensures proxy run only executes when the script runs directly, not when imported. The proxy created here maintains full MCP protocol compatibility, automatically handling routes, sampling, elicitation, logging, and progress reporting through the proxy client transport layer. For non-SDDO transports like HTTP, you'd configure them explicitly in run, such as proxy, run transport equals HTTP, host equals 0, 0, 0, 0, port equals 8080. This pattern is ideal for exposing local services to remote clients or consolidating multiple backends while preserving all protocol features.
Proxy run.
Starts the proxy server in blocking mode, processing all incoming requests through SDDO by default. This is required to activate the proxy. Without it, the configured routes and handlers remain dormant. For HTTP transport or custom hosts ports, you'd specify parameters like proxy, run, transport equals HTTP, host equals 0, 0, 0, 0, port equals 8080, as shown in the official docs. Proxy client pattern. The proxy client creates a transparent bridge between remote MCP servers and local clients, automatically forwarding all protocol features: routes, sampling, elicitation, logging, and progress, without manual handler implementation. Transport configuration happens in proxy.run, where you specify options like transport equals HTTP or custom ports, not in the proxy creation itself.
The
proxy that carries. Every message speaks in silence.